Okay, so I'm giving this limit as x approaches -2 in this rational function. And the first thing that I want to do naturally is replace the x by the -2, because that way is faster, right? So I would just write this like this, and then just solve these operations. Of course, in the numerator, I'm getting 5 minus 4 over 0. This is 1 over 0. Okay, but now, what is 1 over 0? This is this is not defined. This is a problem, because if you remember in mathematics, we can never do a division by 0. You can try to write this in your calculator, but you will get nothing but a mathematical error. The division by 0 does not exist. So what is happening here in this limit? What is this? What this is telling me is that my function is not defined when x is -2. All right, but because this is a rational function, that means one fraction. What this actually means is that there is a vertical asymptote when x is -2. What this is telling me is we have a vertical asymptote at the point -2, and because of that, there are three possibilities for this, for the answer of this limit. The first answer is that this limit is positive infinity. The second possibility is that this limit approaches negative infinity. And the last option is that this limit, of course, does not exist. Why? Because if you remember rational function, we don't know exactly how this one given in the exercise looks. But I know that rational functions sometimes look a little bit like this, right? Approaching from left, approaching from right to this point. Other times they look like this. Boom. And of course, there's a case where you approach infinity and negative infinity, like this. Okay, I kind of remember that rational functions look like this, right? In this case, in the first one, what is the number that I'm approaching in y as x approaches 4 in x? We're approaching positive infinity, right? On this side, the number that I am approaching is negative infinity, because here I'm going down. What happens in these two cases? These two scenarios, you see, from the left I'm approaching positive infinity, but from the right I'm approaching negative infinity. And here, the opposite. From the left I'm approaching negative infinity, and from the right I'm approaching positive infinity. In these cases, in these two cases, it's when we can say that the limit does not exist, okay? These two scenarios. Because remember that in order for a limit to exist, you have to guarantee that both limits from the left and from the right get to the same point. In this case, it is not, because you see, one is going to positive infinity and the other one is going to negative infinity. But in this first two, we can guarantee the limit is either positive or negative, okay? So that is why in this one we only have three possibilities. So now, how are we going to know in our exercise which answer to choose? You see, we have three possibilities. Which one should I use for this one? So what we have to do in this case is find the limit from the left and the limit from the right, okay? And we have to see if they are the same. If they are the same, well, we choose infinity or negative infinity. But if they are not the same, we can say that this does not exist. So first I'm starting from the left. What I mean by from the left is that I'm going to take the number here that I want to approach, -2. And I want to take a number that is on the left side to the -2. For example, it could be -3. It could be -2.5. As long as it is on the left side to the number -2. Um, I'm going to pick a number very, very close here. Let's say -2.1. Okay? And from the right side, very similar, I will take a number that is to the right of -2. That could be -1, 0. But I'm going to pick here a number that is very, very close. Let's say, for example, -1.99. Okay? These numbers here are to the right. These numbers here are to the left. And now what I'm going to do is take this where I left it. So I'm writing 1 over, but instead of writing 0, I will write this denominator as I had it initially, which is x plus 2. Okay? And I will, instead of writing x, I will write the number that I chose from the left here. -2.1. Okay? What I am doing here is approaching from the left in an intuitive way. -2.1 plus 2. Okay? And what is this? I have 1 over, what is -2.1 plus 2? That is -0.1. Okay? And here, you see, in the numerator, I have a positive number, and in the denominator, I have a negative number. Positive over negative gives me negative number. So, from the left side, what this negative is telling me is that I choose the negative infinity here. From the left side, I am approaching negative infinity. From the left. Now, from the right, what I have to do from the right side is pretty much the same I did here. I have to pick a number, in which case here I chose -1.99, which is to the right of my -2. And I will continue from this number, which was 1 over, and again, I am not writing 0, I am writing x plus 2, which is the original form that I was given in the exercise. And now, instead of writing x, I will write this -1.99. -1.99 plus 2. Okay, and what is this? -1.99 plus 2 is something like 0.1, right? Something like this. Like, it doesn't matter to be exactly. All I care about here actually is the signs. Here in the numerator, I have a positive number, and in the denominator, I also have a positive number. Positive over positive is positive. So from the right side, this positive, what it's telling me is that I am approaching positive infinity. Positive infinity. You see here, we have from the left negative infinity, but from the right positive infinity. What this means is that this limit here does not exist. We're falling in a situation like the one here, you see? From the left, I am approaching negative infinity, and from the right, I'm approaching positive infinity. Because I'm approaching different points from both sides, I say that this limit does not exist.